Using explicit formulas for geometric sequences. Because a geometric sequence is an exponential function whose domain is a set of positive integers, and the common ratio is the base of the function, we can write explicit formulas that allow us to find particular terms. A subscript n is equal to the first term times the common ratio raised to the power of n minus 1. Let's take a look at the sequence 18, 36, 72, 144, and 288. This is a geometric sequence with a common ratio of 2 and an exponential function with a base of 2. An explicit formula for this sequence is a subscript n, which is equal to 18, which is the first term, times 2, which is the base to the power of n minus 1. So if we graph this, we know that the first term is 1, and then the output is 18, so we have 118 here. 2 and then 36, 2 and then 36. 3 and then 72, 4 and 144, and then 5 and then 288. Okay, so the explicit formula for a geometric sequence. The nth term of a geometric sequence is given by the explicit formula. A subscript n is equal to the first term a subscript 1 times the common ratio raised to the power of n minus 1. For example 4, we're going to writing terms of a geometric sequences using the explicit formula. Now, given a geometric sequence with the first term to be 3 and the fourth term to be 24, we want to be able to find the second term. So in step 1, the sequence can be written in terms of the initial term and the common ratio r. Well, we know the first term is going to be 3. The second term we know is going to be 3 times the common ratio. We know that the third term is 3 times the common ratio squared, and we know the fourth term is 3 times the common ratio cubed. Now in step 2, we want to find the common ratio using the given fourth term. Well, a subscript n is going to equal the first term times r to the n minus 1. Well, we know that we want to find the fourth term, or we want to find the sequence. So we know that if we plug in 4, knowing the fourth term, we know the fourth term here is 24. So we're going to replace a subscript 4 to be 24. And we know 4 minus 1 is going to give us 3, so we have 3 times r cubed. So again, we know that the first term is 3, and so our goal is to solve for r. And so what we want to do is first divide by 3, so 24 divided by 3 gives us 8. And then we're going to take the cube root of both sides. Well, the cube root of r cubed is r, and the cube root of 8 is 2. So now we can figure out that the common ratio is 2. Now, we want to find the second term by multiplying the first term by the common ratio. So a subscript 2 is going to be 2, which is the common ratio, times the first term. So therefore, 2 times 3 is going to give us 6. Now the common ratio is multiplied by the first term once to find the second term, twice to find the third term, 3 times to find the fourth term, and so on. The 10th term could be found by multiplying the first term by the common ratio 9 times, or by multiplying by the common ratio raised to the 9th power.